Hello guys, welcome to the Have Lab today. My name is Babatunde Arowolo, and today we're going to be talking about multiplying binomials in two variables. Okay, so what a binomial means, basically, as the name implies, bi. Okay, bi means two. So we're going to be working with two equations, like say in this case, this is two here. There are two stuff in here inside the parentheses, and there are also two in here. Okay, so that makes it binomial. Okay, so yeah, we're gonna have to multiply these two equations together and basically simplify the answer. Okay, and this is just like any ordinary equation you'll be given. This is basically the same thing as saying, let's say we have 6. I'm using this as an example. Let's say we have 6 times x plus y. This is basically saying we're going to have to distribute 6 into x and distribute 6 into y, right? So that same approach that we were going to use here is what we're also going to use in this question, okay? So this question is saying x plus 4z times 2x minus 7 and 7z. Okay. All right. So what this means is we're gonna have to distribute whatever's at the front here, whatever's at the front into whatever's behind here. So we'll start from x and distribute x into 2x. We also distribute x into minus 7z, and then come over to the plus here and distribute plus 4z into 2x and plus 4z into minus 7z. Okay, so let's look at that. Okay, so the first step is x. We have to multiply this x because we're basically distributing. We have to multiply x into everything here and here also, right? So x times 2x, okay, because you know when we multiply um x by x, that's basically the same thing as x squared, right? Okay, so since the power here is 1 and the power here is 1, this is 2x to the power 1, this is x to the power 1, right? When we multiply them, the powers out together. So this is x into 1 plus 1, which gives us x to the power 2. Okay, so this is x to the power 1 times x to the power 1. That's basically saying x to the power 1 plus 1, which equals x to the power 2, right? So this is x to the power 2, and then don't forget the 2 in front. So this is 2x squared, and then we're done with this. This multiplied by this gave us 2x squared. So we go into minus 7z from here. So x times minus 7z. Okay. So if you notice, x and z are basically not the same thing. Okay, so we can't multiply it like the way we did over here. Okay, but we can just fill in x. We can just replace. We can just fill in x into minus 7z. And by filling, what I mean is by saying when we multiply minus 7z times x, you can just say, since there's nothing common between both sides of the multiplication, we can just include x into this part. Okay, so we say minus 7xz. Okay, so we can do that since x and z are not the same. We can't do what we did over here with what we did here. Okay, so this is basically minus 7xz. Okay, and next we have to work with plus 4z because we're done with x now. Okay, so we have to work with plus 4z and multiply it by this one and also this one again. Okay, plus 4z times 2x. Okay, we know z and x, they are not the same thing. Okay, so we can't do what we did over here. So basically we're going to have to do what we did here with plus 4z and 2x. Okay, so plus 4 times plus 2, let's work with that first. Plus 4 times plus 2, that's a plus 8, right? That would be plus 8. And then z times x, z times x, basically xz or zx. It doesn't really matter what order you put it. Okay, so I want to put the one first, the letter first, the letter that comes first before the bigger letter. Okay, so this is x 8xz, and then we come over here 4z and then minus 7z. Okay, now we know z and z are actually the same, so we can do what we did here with here, right? So we can say z times z equals z squared. Okay, so we know z times z equals z squared, right? So that would be plus 4 times minus 7 in this case now, right? That's what we're left with. Plus 4 and minus 7, that's a minus 28. Because when we multiply plus times a minus first, that gives us a minus, okay? 4 times 7 gives us a 28, right? And then z times z, what we did over here, give us a z squared. Okay, so now we're left with 2x squared minus 7xz plus 8xz minus 28z. Okay, I'm sorry, my handwriting is not the best, really. Yeah. Okay, so that's what we're left with for now. Okay, but we're asked to simplify the answer. And if you look at this, this although it's solved, this is z squared, sorry. Although it's solved, right? It's not simplified. Okay, and the reason it's not simplified is because there's an xz here and there's also an xz here. Okay, we can work with this two, right? Basically, you can work with them because they have the same amount of letters and they have the same letters. Okay, so since they have the same letters xz and xz, so that means we can work with them. Okay, so basically this just means minus 7xz plus 8xz. Okay, so minus 7xz, you're going to treat this like you treat any number. Okay, so you're going to treat this like you treat minus 7 plus 8 also. We know minus 7 plus 8 equals a 1, right? So that's how we're going to treat this also. So this is a 22x squared. This is a 1, also a plus 1. You can also say plus 1 too. Okay, plus 1 times, or you can just say plus 1xz. Okay, so we left the letters here because they're actually the same, and there's nothing more we can do. We can just work with the numbers in this case. Okay, plus 1xz minus 28z squared. Okay, so it doesn't really matter if you have a 1 in front, you can remove it. Yeah, it's mostly advisable to remove it. So yeah, okay, so you can just say 2x squared plus xz minus 28z squared. Okay, so we remove the 1 in front of the xz. Okay, so it can be, so yeah. Okay, so let's put that in. Just 2x squared plus xz minus 28z squared. Check. Okay, correct. Okay, so let me go back on what I did here. Okay, so what I did was I distributed what was at the front of the parentheses. Okay, I distributed x into 2x and minus 7z, which is what I did here. I distributed these two, and then I distributed 4z into the 2x and minus 7z again. Okay, and when I was distributing, I came across variables that had the same letters. Okay, since they had the same letters, I could multiply them together, right? So when I multiplied, in this case, x times 2x, that gave me 2x squared. Because x times x is an x squared, and 1 times 2 is a 2, right? That gives us a 2x squared. But when I came across some numbers that didn't have the same letters, like say for example x and 7z, right? X and z were different letters, right? So the only way to multiply these two different letters is to put in one of the letters into the other expression. Okay, so I put in x into this minus 7z expression. So when I put in x, that gave us minus 7xz. Okay, so minus 7xz was what was here. Okay, and then after that, I came over here and did the same thing with 4z. Okay, I worked with 4z and I kind of distributed it throughout. So after I finished distributing it throughout, I came over here and I realized that we had to simplify it. Okay, and for us to simplify it, simplification basically means putting it in its simplest form it can ever be. And when I looked at this, it wasn't in the simplest form because we could break it down more. Okay, we could break down minus 7xz plus 8xz also. Okay, and when we break that down, when we say minus 7xz plus 8xz, that gives us a plus 1xz. Okay, so now it's kind of smaller than it was before. So that means it got simplified, right? And so since it got simplified, this is the most simple form can ever be. And since this is the most simple form can be, we've already simplified the answer, right? And after simplifying, we just put in the answer in here, and yeah, that's it. Okay, so thank you very much for watching the video, and I really hope it helped you out. Have a beautiful day ahead. Bye.